Hello everyone, welcome back to the fast track revision series of UGC NET Electronic Science. So we are discussing in the previous class about modulus counters. So this class will be the continuation of that. So sometimes they may give the questions like this. So determine the modulus of following counters. They may give like this. So this is a counter circuit. Q3, Q2, Q1, Q0 represents, all these represents flip-flops. Okay, so all this represents flip-flops. I'm telling you the representation here. So these inputs represents the clear input. As I've told you, there will be two inputs, one is preset and clear. So if clear is given as 0, right, so because this is active low, here it is given active low. Sometimes he may give you active high also. So in that case you have to give clear is equal to 1. Right, so when you give clear is equal to 0, all the flip-flops will be cleared. So all the flip-flops will be cleared. So all the flip-flops will be cleared means it will be again comes to the state of 0 0 0 0. That means counter is reset. Counter is reset. So we know the concept here. So if 3-bit counter is there, suppose if 3-bit counter is there, it counts from 0 to 7. So after 7 it again reset to 0. So here also the same concept. So clearing the counter means making it to reset to 0. Okay, so after 7 it is now getting back to 0. So that is why we will call this as mod 8 counter. Mod 8 counter. Okay, now see this case also, right? So understand the concept clearly. So this is clear is equal to 0. So when clear is equal to 0, this counter will be reset. First condition for first point you have to remember is, so all these represents flip-flops, that is the first point. And these inputs represents clear output, so it is CLR bar. That means it is active low input. So you have to give clear is equal to 0 in order to reset the counter. That is the second point you have to remember. Now if you observe here, this NAND gate, so this is an NAND gate. So this is this NAND gate is connected to Q1 and Q3. So in order to give this input as 0, so what will be the output of NAND gate? So output of NAND gate should be equal to 0. So then only you can give 0 to all the clear inputs and you can reset the counter. So for resetting the counter, output of NAND gate should be equal to 0. Okay, try to understand the concept clearly. So when output of NAND gate is 0, so output of NAND gate will be 0. When will be the output of NAND gate 0? When both the inputs are 1. For AND gate, if both the inputs are 1, output is 1. For NAND gate, when both inputs are 1, then only output is 0. So this should be equal to 0 and this should also be equal to 0, so that this becomes 0 and counter will be cleared. Okay, and these values can be 0, right? So these values doesn't have any condition, so these values must be equal to 0. So for this NAND gate, or to clear this counter, what is the states of Q3, Q2, Q1 and Q0? So Q3, Q2, Q1 and Q0. Since Q3 and Q1 are connected to NAND gate, they must be given with 1 and 1. So 1 and 1. And since Q2 and Q0 are not connected to NAND gate, they can be 0. So they are 0. So when you are given with 1 0 1 0, when you are given with 1 0 1 0, okay, so if you are given with 1 0 1 0, so you are giving 1 1 here. So when 1 1 is given here, so output of NAND gate becomes 0. So this 0 is applied to clear input, so it is going to reset. So the next state will be 0 0. So when you are giving this state, the next state will be 0 0 0 0. Okay, so when you are giving 1 0 1 0, the next state will be 0 0 0 0, because all the flip-flops will be cleared, so it will be reset. Same concept as here. If you are giving 7, so if you are giving 7 next state will be equal to 0. Similarly here also 1 0 1 0 next state will be equal to 0. Okay, so what is the modulus of this counter? So mod value is equal to 10. 1 0 1 0 represents 10, so mod value is equal to 10. That means this counter counts from 0 to 9. 0 to 9. When 10 is encountered, so 10 is encountered, it will be reset to 0. Okay, so clear the concept. So if 10 is encountered, it will be equal to 0. So 10 is encountered, it is equal to 0. So it will be mod 10 counter. Okay, right. Same here. So output here, this should be equal to 0 because they are active low clear inputs, right? So all these are clear only, so active low only, so output of this should be equal to 0. When output of OR gate, so this is now OR gate, not the NAND gate. Based on the gate and based on the clear input, whether it is active low or active high, the question changes. Okay, right. So this is OR gate. So our output of OR gate is 0 when all the inputs are 0. When all the inputs are 0, so Q3 bar is equal to 0 and Q2 is all not connected, so it is obviously equal to 0. Similarly Q1 bar is also equal to 0 and Q0 bar is also equal to 0, but we don't require Q3 bar, we require Q3. So when Q3 bar is equal to 0, then Q3 is equal to 1, and obviously Q2 is equal to 0. Q1 bar is equal to 0, so Q1 is equal to 1, and Q0 bar is equal to 0, so Q0 is equal to 0. So the modulus number will be equal to, Q0 bar is equal to 0, so Q0 is equal to 1. So modulus number is given by Q3, Q2, Q1, Q0. So 1 0 1 1. So it will be mod 11 counter. 1 0 1 1 represents mod 11 counter. Just remember this point. So for whatever the value the modulus comes, so that will be the modulus of the number or modulus of the counter. So for whatever the values you are getting Q3, Q2 and Q1 and Q0. So here it has given Q3 bar. This is the important point which you have to remember. So he has connected the external gate. He has not connected the flip-flop to that. He has connected flip-flop to the external gate, and through the external gate he is making the counter to clear its input. Okay, so to clear the flip-flops, he is using some external gate, right? So practice some more questions. You will get addicted to this methodology also. So this is the possible way of asking questions in modulus counters. These are the only types of questions that is asked in many competitive exams. Okay.